Welcome back, tech enthusiasts, to another exciting episode of Operating Systems Crashcast. I'm your host, Victor, and joining me today is the brilliant Sheila. We're continuing our journey through Season 1, Chapter 1, Introduction to Operating Systems. Today we're diving into Section 1.7, Memory Management. Are you ready to explore the intricate world of computer memory, Sheila?
Absolutely, Victor. I'm excited to unravel the mysteries of memory management with our listeners. Before we jump in, let's remind everyone that we've already covered process management in our previous episode. Today's topic is closely related, as memory and processes go hand in hand in the operating system world.
Great point, Sheila. Now, let's kick things off with our quiz time. Here's a question for our listeners to ponder. What is one of the primary functions of memory management in an operating system? Keep this in mind as we explore the topic, and we'll reveal the answer at the end of the episode.
That's a great question, Victor. I'm sure our listeners will have some interesting guesses. Now let's start with the fundamentals. Memory management is a crucial function of operating systems that involves organizing and controlling the computer's main memory. It's responsible for allocating memory to various processes, ensuring efficient use of available memory, and protecting memory spaces from unauthorized access.
Exactly, Sheila. To help our listeners visualize this concept, let's use an analogy. Imagine memory management as a librarian in a bustling library. The library represents the computer's memory, and the books are like data and processes. The librarian's job is to keep track of which books are available, where they're located, and who's borrowing them. Similarly, memory management keeps track of available memory, where data is stored, and which processes are using it.
That's a fantastic analogy, Victor. It really helps put things into perspective. Now let's delve a bit deeper into the main functions of memory management. First and foremost, it handles memory allocation and deallocation. When a process needs memory, the operating system allocates a portion of the available memory to it. When the process is done, that memory is freed up for other uses.
Absolutely, Sheila. And just like our librarian needs to efficiently use shelf space, memory management aims to use the available memory efficiently. This involves techniques like memory compaction, where the OS moves processes around in memory to create larger contiguous free spaces, much like reorganizing books on shelves to make room for new arrivals.
Great point, Victor. Another crucial aspect of memory management is keeping track of which parts of memory are in use and which are free. This is similar to our librarian maintaining a catalogue of which books are checked out and which are available. The operating system uses various data structures and algorithms to manage this information efficiently.
Exactly right, Sheila. Now let's talk about a more advanced concept, virtual memory. This is a technique that allows the operating system to use secondary storage, like a hard drive, as an extension of the main memory. It's like our librarian using a storage room to keep less frequently borrowed books, bringing them out when needed.
That's a great explanation, Victor. Virtual memory allows the operating system to run processes that are larger than the available physical memory. It does this by swapping portions of the process in and out of main memory as needed. This gives the illusion of having more memory than is physically present in the system.
Absolutely, Sheila. And this leads us to another critical function of memory management, memory protection. Just as a librarian ensures that patrons don't access restricted books or damage borrowed ones, the operating system must protect memory spaces from unauthorized access or modification by other processes.
That's right, Victor. Memory protection is crucial for system stability and security. The operating system uses hardware support, like memory management units, MMUs, to enforce these protections. It ensures that one process can't accidentally or maliciously access or modify the memory space of another process or the operating system itself.
Excellent point, Sheila. Now let's talk about some of the challenges in memory management. One significant challenge is fragmentation. This occurs when free memory is split into small non-contiguous chunks, making it difficult to allocate large blocks of memory, even when the total free memory is sufficient.
Absolutely, Victor. Fragmentation is like having empty spots scattered throughout our library shelves. making it challenging to shelve a large set of encyclopedias together. Operating systems use various techniques to combat fragmentation, such as compaction, as you mentioned earlier, or using more sophisticated allocation algorithms.
Great analogy, Sheila. Another challenge is balancing performance and efficiency. The operating system needs to manage memory in a way that minimizes overhead while still providing fast access and efficient use of available resources. This often involves trade-offs and can vary depending on the specific requirements of the system.
You're absolutely right, Victor. It's a delicate balance that operating system designers must carefully consider. Now, as we wrap up our discussion, let's recap the key points we've covered about memory management.
Excellent idea, Sheila. We've learned that memory management is a crucial function of operating systems, responsible for allocating and deallocating memory, keeping track of memory usage, implementing virtual memory, and providing memory protection. We've also discussed challenges like fragmentation and the need to balance performance and efficiency.
That's a great summary, Victor. Now, let's return to our quiz question. What is one of the primary functions of memory management in an operating system? Based on our discussion, one key function is memory allocation and deallocation, the process of assigning memory to processes when they need it and freeing it up when they're done.
Excellent answer, Sheila. I hope our listeners found this exploration of memory management enlightening. Thank you all for tuning in to Operating Systems Crashcast. Don't forget to subscribe for more exciting episodes as we continue our journey through the fascinating world of operating systems.